Welcome everyone, and thank you for joining the presentation today. This I would regard as part 2 of the presentation that I did in January, and I just did not want to repeat myself as the video for the previous presentation is also available. And in the previous presentation, we talked about really the core use case that Lexus Nexus built the HPCC platform for, which is really the business around Lexus Nexus itself, which is assimilating data around people and businesses across the United States and internationally now, and then providing risk-based services. Today, however, I'm going to focus on a use case around cybersecurity and walk you through some of the critical aspects of data governance and data processing requirements that enable us to do this very efficiently in HPCC systems. Let me just step back a little bit and talk about how my role has changed. Back in January, I was more on the sales side, where I was really selling HPCC to the audience. But more recently, my role has changed to really being the user of HPCC, where I am now responsible for building the next Lexus Nexus cybersecurity telemetry data lake for security. And there has been several interesting challenges around this, and I'm going to walk you through that, and I'm going to show you why we thought eventually HPCC was the solution to use. We did explore, since I'm on the other side as a customer, I needed to explore all other options. We did explore several other options, but we came back again to HPCC just because of some of the key strengths that it has. Okay. Now, before I dive into the actual, reasons why we are leveraging HPCC and how we are leveraging HPCC, let's step back a little bit and understand the use case and the requirements on the use case. So in the cybersecurity world, in this particular instance, we are talking more about with regards to infrastructure that is stood up in the cloud environment. So I want to make sure it's not relevant too much to on-prem environments. It's more with regard to how we develop applications in the cloud environment. And Lexus Nexus has been progressing to move all their infrastructure to the cloud environment. And that is why we started building this telemetry data lake. Now, when we talk about cloud environment, really our focus comes back to, as users of the cloud environment, is really the focus is on the development of the web application itself, or any application for that matter that we deploy in the cloud environment. There are really 3 focus areas that we have to be bothered about as far as the web application and the web application security is concerned. One is the code that we develop. Is the code secure or not secure? And how do we make sure we have a consistent and secure process in developing this code? And the second most important aspect is, in most cases, we might be developing 10% of the code, but using 80% or 90% of external libraries. Or, we might even say, we can say that we might be developing 20% of the code and literally using 80% of external libraries, right? For example, if you develop a web application, the user interface elements could be a third-party components. We want to probably spend the time to start developing those HTML, AJAX-centric components ourselves, right? If it's already been developed and it's already been well tested, we might leverage that. Same thing with accessing a database or a service. We will leverage the libraries that are available to access the database, like JDBC or ODBC drivers and so forth. So these are all typically third-party libraries that are provided to us, or we have purchased them and then we use it in our application to build our use case out. So that is an important aspect of the entire application. And third, but not least, is once we move to a more virtualized setup like a cloud environment, we use cloud-based services. In our case, we use Azure, and we use Azure services across the board, focus mainly on using AKS, which is Azure Kubernetes services. We use their SQL Server databases services. We use Cosmos DB. We use App Services Stack and so forth. But the important aspect I want you to keep in mind is we are kind of a layer on top of the infrastructure. We don't own the infrastructure. That's Microsoft provisions the infrastructure. They've created a virtual environment around it, and they've provided these services on top of that. So we are interacting with these services, so as to speak. Now, as far as security is concerned, obviously, with regards to our code development, we have to make sure our code is secure. And how do we do that? We do that by incorporating very secure development processes. In the sense, we do code scanning, we do dynamic code testing. We do penetration testing. We also make sure there's code reviews. There's a systematic CI/CD pipeline when we push out code from one environment to the other. So there's a lot of things that go into making sure our code is secure, and we have the checks and balances around that. Obviously, if you're looking at hundreds of products that are being developed across the Lexus Nexus ecosystem, we need to somehow make sure there is a trust but verify setup, right? Trust is really around making sure we have a secure development lifecycle, but at the other side, we also need to ingest all these data points of all the security scans, and and bring it all together to indicate to the stakeholders, look, this application needs improvement or it is secure. And then on the third-party library side, again, we will have to keep up with, what are these third-party libraries that we're using, and are they being used for the right reasons? And once we know they're being used, we have to make sure that they're constantly tracked to make sure there are no vulnerabilities. If there are vulnerabilities, we have to ensure they are fixed on time, because ultimately, if this is a web application, and even though your code might be fully secure, you followed all the guidelines to the dot, but there is an external library that has a vulnerability and your code is using that, then your code is literally, your application is exposed for a hacker, right? They are going to make use of that vulnerability and then get into your application and your data, and you want to avoid that. And that is why you need to have a systematic process of being able to scan for those data assets and then provide remedial solutions. And similarly for the cloud infrastructure, again, there's certain things that the cloud provider provides you, but if you're using a virtual machine, for example, and that means you're deploying your own operating system and you're managing all the vulnerabilities that relate to the operating system. So you need to have agents kind of running on these operating system, gathering information and making sure that the vulnerabilities are addressed as well. So these three things, if you're trying to push anything to the cloud, as a company, as an application developer, you need to be mindful of these three areas in general. Okay, now talking about one of the critical data sources for the information that flows into our system for analysis is the CVE database. So the CVE database was established in 1999, and it really tracks all the common vulnerabilities that companies and third parties have published. So if you're using a common library like Log4j, or an application that is more famous as a third-party application. So the vendors who provide these applications, like Microsoft or other vendors, they are required to publish a discovered vulnerability and the information on this vulnerability to this database. This is a shared model in the sense the idea is if you publish a vulnerability that is you've discovered as a vendor, and it can be addressed by your customers by actively using your new patches, then the chance of the application being hacked reduces drastically. So they have created this nice database that all of us leverage and ingest the data from, and based on the vulnerabilities that are discovered, we can then take these vulnerabilities and compare it against our asset repository to make sure these vulnerabilities are not there within our ecosystem. If they are there, if we find that these vulnerabilities are there within our ecosystem, then we have to address them based on the criticality, right? So that in essence is the CVE database. Now, the other aspect of vulnerability management is, how do we collect data from, the cloud infrastructure or infrastructure that we are deployed to our employees is by an agent-based approach where we have agents running on this infrastructure. These agents could be from companies like Qualys or Defender from Microsoft, and they collect the same information, which is, are there any vulnerable software running on these devices, whether it's a database or virtual machines, workstations, anything. Are there any vulnerable pieces of software that are running, and they compare it against the CVE database that I just mentioned. And if there are vulnerable pieces of software that are running, they report it to a central log database. And that is a critical data source for us. Okay. Now, slowly but surely, we are coming to how we are leveraging the HPCC ecosystem to absorb these data sources and then use the power of HPCC to produce some key results, actionable results on the other side, so that we can then mitigate the circumstances around vulnerabilities, right? So starting from the left-hand side, we have the raw data sources. We typically use Python scripts to be able to integrate into APIs that some of these data sources provide us, and we integrate that. In other cases, it might be really we don't have an API. It might have to be extracts of data from their application, like in a CSV format or XML format or JSON format, and we have to bring that data into our sources. So you can see some examples of it as the CVE database that I spoke about. Then we have data sources for scanning our own source code to make sure our source code is using best practices. Checkmarks and Burp Suite is some of the tools that we use, but there are several. It depends on what tools we want, and we also have to be mindful. In our case, when we're building out this data lake, tomorrow we might change a tool, and we might need to absorb or ingest information from that tool very quickly, right? And for external libraries, we typically use GitHub's Dependabot and a third-party tool called Mend. This is enough information that shows us that these third-party libraries that we're using are vulnerable and they need to be fixed immediately. Infrastructure scanners, we have several. We're still expanding on those, but primarily Qualys, Defender, and Prisma, right? Other sources, obviously, we have to be in tune with understanding what the ecosystem of our user profile is, using our LDAP and Azure AD systems. And once we ingest this data, we go through the process of now understanding this data. Remember, these data sets, yes, they're kind of partially clean. They have enough information. They're coming from a system that already has data, so they're not rough data. They're not completely unclean, but they will need to be ingested and normalized. And that's when the flow starts to progress through our HPCC system. And one of the things that we do with any of the data sets is before we process it, there's a system for profiling this data, in the sense, has anything significantly changed between what we saw yesterday from the same data set and what we are seeing today. Because if we notice that significant change too late in the life cycle, then what will happen is all the assumptions that we make here in the analysis might be completely wasted. In the sense, there might be a error in the incoming data that might throw off our entire integration analysis entirely. So that's why the profiling step is important, and we have tools in the HPC systems to build that into the pipeline very quickly. And based on the outcome of that profiling step, we can fire off rules whether to proceed next or whether we need to get in there and manually do something with regard to the data that is coming in. So I'm just giving you, as I make progress through this use case, some examples of why these steps are important. And then the whole, cleaning and standardization, really around, tools that HPCC provides around quickly being able to take one data element and convert it to something that's more standardized across the board, so that when we push it down the streams, it goes in a standard format to everybody across the board. And the last but not least of the data integration process is linking this data. Since we are getting all these data sets across different data sources, we need to be able to then collate it and link it together so that, for example, if you're looking at an application that I showed in the previous slide, we want to come up with some sort of a risk score all around this application. This application is, has source code that is fairly secure. It has third-party libraries, maybe not too secure, and it's deployed in a cloud environment that has not been completely secured. So what is the score? We might give it a score of, 60 out of 100. And that means that score should be a red alert on somebody's dashboard saying, okay, this particular application has issues and we need to address that, right? So that is what the whole linking and enrichment process is all about. How do we make this data that we have ingested much more richer and, to a point where we show this as a clear critical score to somebody to take action, make it actionable. And then when we keep going through the process, we're kind of getting the data ready for others to consume, whether it's through an API or a batch file system, Power BI, or we are going to send this to a vector database. I'm going to talk a little bit about the vector database a little later, but the idea is to send this in a way that they can ingest it in a very systematic way and very quickly. And that is where the index builds come into play. If we want to provide an API that provides quick access to this data, then they have to, you access the data in an indexed manner. So we have that system built into the HPCC ecosystem. And then the last but not least in the publishing workflow is just the API publish and delivery of this data across the board. Now, one of the key things that we are building is, keeping all the, I wouldn't call it hype now, it's gone beyond the hype with regard to ChatGPT and LLMs, is, we know that this is a very useful technology, but we cannot just rely on the information that is out there that is really built around the model around this ChatGPT interface. But what we really want is, how do we make this much more richer by using our database, our vector database, then set the right context to it so that when somebody comes and says, hey, this particular vulnerability, tell me where in our ecosystem does this vulnerability show up? The ChatGPT, our interface response should clearly say, yeah, this is the mitigation steps that you have to take. And by the way, it is these vulnerabilities are now on these servers, these workstations, and you have to take this action, right? So context relevant information and very quickly absorbable information. Okay. Let's go to the next slide. Okay, now diving into slowly but surely into the ecosystem of what HPCC is. Again, HPCC is broken down into really two key components, right? One is called as TAR. As you could see through our use case, quite a lot of the information that is flowing in is based on batch information. There is a lot of files coming in, whether it's absorbed through APIs or direct file extracts, they have to be ingested in a quick manner across the board. And I also noted some of the analysis that has to happen in these ecosystems to make it brought together so that when we show it on the other side in a Power BI report or through LLM interface, that it is something that is really relevant and actionable. So that is what the TAR process or the TAR component does. It can spawn from a single virtual node to hundreds of nodes if you want to, depending upon how much power you need with regard to the processing requirement. It can scale very well. In fact, we have our scale sets within some of the environments that we have set up in Azure has literally 500 nodes or more, right? Now, once the data is ready and this data can be absorbed by others, we have another system for that, which is more optimized around delivery of data. So if people want to quickly absorb this data using an API, then TAR might not be the good interface to use or the good component to use. You need a system that is really tuned to delivering the data very quickly in real-time fashion, sub-second fashion, and that is the Roxy cluster. It's tuned to absorb the data, well integrated into TAR. So any workload that goes through TAR will flow automatically into Roxy as far as when it is published, so that on the other side, data can be quickly absorbed and then published. And then in addition to this, we have the ECL programming language, which is a common programming language for TAR and cluster. I'm going to dive into ECL a little bit later, but the key aspect of ECL is it's kind of very similar to SQL. It's very similar to pandas in the sense it's declarative in nature. You just tell it what you want done and how it actually builds that execution flow is really very similar to how SQL does it, right? In SQL, you simply say select star from this, you select field name from here, and join these tables. It's the same concept here in ECL too. It's very simple to use. And then finally, the execution graph takes care of optimizing the data. If it needs to use indexes to do the search and bring it all together, the execution engine takes care of that optimization, so that we, the ECL developer, focus only on really the what aspects of getting the job done. Okay. In addition to this, we have ancillary components for managing the data. Some of this I mentioned with regard to data profiling, handling multiple files together, scheduling, and delta file handling. If it changes to a single data source, but only minor changes every day, how do you handle that? All that is kind of built into the data management aspect. And the other is the query development. Okay. Just stepping back here a little bit, and feel free to ask any questions, and then I'll be able to answer them as soon as I get to it. So just stepping back a little bit and talking about Lexus Nexus. So look, Lexus Nexus started this company around 2001 timeframe. We were building a unique use case for one of the credit bureaus. They had a workflow that ran for 25 days, and they came to this small company that time in Boca Raton, Florida, and said, "Hey, can you solve this problem for us?" And this company had a few, really sharp people from Boland International working for them, and they put them to work. And lo and behold, whatever was running for 25 days ran in literally 5 hours, right? And that is how the first version of HPCC started. And once after that, the main events happens to be the acquisition of ChoicePoint in 2007, which is the company that I work for. I used to work for ChoicePoint, and when became part of the Lexus Nexus brand once ChoicePoint was acquired out of the Atlanta area. And one of the biggest things that came out of that is ChoicePoint had a lot of mainframe-based data that relates to insurance. The entire mainframe aspects of processing the data was converted to HPCC. Huge performance improvements, huge savings. It benefited a lot of the insurance, current insurance carriers tremendously just because of that improvement. We open sourced HPCC in 2011, mainly because we saw there's a lot of need in the open source market for data, big data products, and we said, you know what, this is the right time. Let us open source it. Let us make it available to community. And if there are any use cases the community needs, let them come to us, and we'll make it even better. And that way, even Lexus Nexus benefits from something that gets better because of contributions from the community and so forth, right? Another critical aspect is, from the 2019 to 2020 timeframe, we started working on developing the HPCC platform on the cloud. That means we needed it to be scalable from literally nothing to running a workload, but dynamically, right? Using Kubernetes as kind of the key platform. So we migrated our components to work seamlessly on Kubernetes. And some of the benefits of doing that you'll see in our use case that I'm going to reflect in a few slides. Okay. Any questions so far? Any questions? Let me pause there from you a few minutes. Okay, so let me carry on. So again, coming back to why did we choose HPCC Systems for this particular cybersecurity use case, right? One of the biggest benefits for us to use HPCC Systems is the way that file data and data incoming into the system is handled in a very systematic manner, right? So obviously, for the cybersecurity action committee, the people who take action on information, as soon as something is discovered in our environment, it is critical to reflect that very quickly on the other side. If there's a delay of a few hours, it might be fine. But if there's a delay of days before they know that their system is vulnerable, then by then it could already be hacked, right? So it is a critical environment where we, on one side, need to ingest this data on batch. It's not like others, we are ingesting information in real time, and the access on the other side is real time. On one side, it is really batch oriented. Data is coming in a lot of different work streams, a lot of data sources, different formats. We have to ingest that in a meaningful manner and quickly progress it to the other side. So at least, within a 24-hour cycle, we have critical up-to-date data on the other side, okay, to be able to consume. So HPCC provides us the hooks, critical hooks to do that. For example, if you're talking about bringing in, hundreds of files that correspond to a single data source, HPCC provides a nice way to treat all these 100 files as one single logical file, which is important. Then when we do the actual query, like we do in ECL, we can see that file and query that file as a single file. Behind the scenes, really, what HPCC does is it still treats those individual, that single logical file as individual files. It brings it together as what we call as a super file, and that makes our life so much easier. So for somebody who's working on the system, for example, all that they need to do is push data into a specific landing zone directory. And if the data is there, everything else after that is fully automated. It flows through the next level of, okay, now creating this logical file and making it available to the ECL layer for processing automatically. And that is one of the critical aspects of why we like HPC. We looked at other platforms, Databricks. We looked at other similar platforms. Yes, you can potentially build all this in those platforms, but there was nothing out of the gate that made it so easy to use, and that is what we like with regard to HPCC. Then the other critical aspect of it is, as I mentioned earlier, it is so closely integrated with the Kubernetes ecosystem. So just to step back, anything that is running on Kubernetes gives us the huge flexibility around automatic scalability in the cloud, right? Because when you run resources constantly in the cloud, like how we run resources constantly on-prem, it'll become very, very expensive. So one of the critical aspects of running any workloads in the cloud is we should be able to scale it on the fly so that we run the workload only for the duration for which we need to run it, and then scale it back down to the minimum requirement after that. Kubernetes provides the framework for accomplishing this very easily and very systematically, right? So one of the critical things after our 2019 roadmap was to make sure HPCC Systems is completely integrated into the Kubernetes ecosystem. And as you can see in this diagram, that is what we do. Now, one other aspect of Kubernetes is, look, we do not need to use Kubernetes just for HPCC. Kubernetes can also run any other workloads that you want to run in that environment in a similar fashion, and you can set it up to scale in the similar fashion that you do HPCC. So if HPCC pods are not running, then why not leverage that time frame to run some other pods if you need to run it, right? So that way, when we want to ingest data from our sources, we can have our Python scripts be enabled to run during that time. And our Python pods are executed and they absorb the information from those data sources, and then the data then flows into our storage account layer. The beauty of this architecture is we hardly have to move data anywhere once it is ingested, because as soon as it is ingested, it really goes down to the storage account layer, which is now available to be ingested, at any endpoint tools that you want, whether it's a SQL Server database or Power BI system or Databricks for that matter. Anybody can ingest this data that is now available either in file format or Azure table format or Azure blob format, right? So that is the whole benefit of using AKS. And then just because HPCC is so well built into AKS, it makes it a no-brainer to use the system, not just for HPCC, but for everything else that we want to build with regard to Python and Python workloads. So that it gives us all the flexibility. Okay, now jumping back into ECL, as you recall, I mentioned that ECL is very similar to Pandas, similar to SQL as well. You need to, when you're working with ECL as a programming language, you really need to be familiar with mainly these functions or actions, what we call them as actions, right? So if you know how to work with these functions, then you're well on your way to being an ECL expert. And that's pretty much it. When a data set comes in, you obviously need a data set operation, and after that, you have several of these operations that are used for transformation and linking and bringing the data together. Again, this table illustrates what are the equivalent functions on ECL side and how that compares to Pandas, for example, right? In SQL, a select would be equivalent to a table function here, for example. In SQL, select join would be equivalent to a join function in ECL, and so forth. So a little more powerful than SQL, obviously, just because it does a lot of transformations, So we do a lot of transformations and shaping of the data, and ECL provides you that capability very easily. Okay. So ECL again is a very data-centric language. When I say data-centric, in the sense it's been designed to actually define the what, and not so much as to define the how, right? It's not like you're programming in Java or Python where you define the loop structures and you progress how the control flow has to go through. You typically do not do that at all in ECL. In ECL, you simply come out and define what are the incoming layouts. Again, this is all at a runtime, right? You can say your record layouts are defined like this as an input record. This is what is coming out from my input CSV data file, and my output record looks like this. And here you can see the definition of a data set. A data set in this particular example, for clarity's sake, I'm not fetching the data from the disk. I'm embedded this data here to show you how easy it is. Now, if you really want to fetch the data from a disk, you'll simply uncomment this line and comment this part out, and everything else remains the same, right? And it's very straightforward. So we support CSV, JSON, XML, and fixed length formats out of the gate. There is work being done on Parquet support as we speak. All that is coming down in the following months. And then this is a really foundational transformation structure, and it's called project. Understanding this will give you an emphasis on what ECL is all about. So what project is telling us here is, look, I have a data set, an incoming data set, input data set. All that I want you to do is go through each record and apply this transform. So in a non-declarative programming paradigm, it's like a loop. You're saying loop through this data structure, this data set, and for each record, apply this transformation, right? So you can see on the right-hand side what the project is doing. So it's taking this input raw data structure and formatting the date into this format. So that very simple example, but it kind of gives you what HPCC ECL is doing. Now, this data can be millions or billions of records potentially, right? It does not necessarily mean it's just a few records like here, but it can be millions of records, and the code exactly is going to be the same. But behind the scenes, what happens is this is actually broken down to an execution graph like you see on the right-hand side. This is very similar to what happens in SQL. When you type in a SQL statement and execute that, the SQL engine, whether it's Oracle or SQL Server or MySQL, they take that SQL statement, optimize it, and convert it to an execution graph and execute it. Similar concept here. This is the equivalent of an execution graph. And many times when you do an execution, when we go and view the actual execution graph, you can see it's kind of slightly different from the actual code that you execute, because the ECL optimizer realizes what are the steps to optimize this and execute it. So not only does it optimize the execution flow, it also makes sure that the data is distributed across n number of nodes if you want to, and then each of these execution processes happens on each node independently. Once that execution happens, it brings all the data together eventually automatically for you, without you having to do any of those steps within your code. Behind the scenes, ECL and HPCC takes care of the optimization steps and distribution of the data. Okay. Just stating those. Now, how do we code ECL? Obviously, in the modern day coding paradigm, if you don't have a well-functioning IDE, it's going to be very difficult to code in any programming language for that matter. So obviously we do provide a fantastic plugin for ECL coding, whether you want to work in the VS Code IDE or you want to work in like a Gitpod IDE. We have plugins available for both, and it works with syntax highlighting, all the features around compilation, execution, all that is built into these IDEs. We also do support workbooks where it works similarly to how the workbook works in other environments like Spark, Databricks, and so forth. Similar concept, you can code ECL into a workbook and execute that. Lately, we have built integration into Power BI so that the data that you see progress from one environment to kind of the Roxy environment is now available to Power BI environment, whether it's through Azure Tables or through more like a hybrid data lakehouse kind of concept. You can use that with Power BI. Tombolo is our workflow-centric data management tool. It provides capabilities around using a user interface for drag and drop to do some of the transformations that I showed without actually writing ECL code. But it also provides you a nice orchestration layer of executing jobs in a systematic manner across the board. So this is the tool that provides a user interface around some of the concepts that I discussed earlier for tracking data movement from one environment to the other environment, recording metadata around each data set, searching for a published data set, managing this data so that certain aspects of the data are monitored to see if they contain sensitive data. Can these sensitive data elements be shared with others? So the entire governance around data, that is the tool. Tombolo is a tool that incorporates those things. ECL Watch is our standard administration console for everything HPCC and ECL. Very easy to use interface. It gives you entire flexibility to perform different aspects of HPCC and ECL in a single administration console. And the data profiling is also built into various aspects, whether it's into the IDE or into the ECL Watch console. All that is brought together nicely in this ECL Watch interface. Okay. Last but not least, look, HPCC has been around for a long time. We have a wealth of information across the board, whether it's white papers or detailed documentation or presentations and constant involvement in the community. We are there, and the reason is that we truly believe this is a fantastic platform. And when I jumped on this platform as a user, I had my doubts, but soon I realized, look, there's nothing to beat this platform for this particular use case. Is HPC a fit for all use cases? No, right? If you are doing something that is aligned to do with the use case I described, there are cybersecurity infrastructure, it's the perfect use case to use HPCC. And we have significant amount of large customers, they do the same thing and they benefit from HPCC as well by incorporating it in this particular use case. They also integrate, whatever elements come out of HPCC with something like Databricks very easily, because Databricks is much better in machine learning aspects, for example, right? So yeah, absolutely, we have a close integration with these different layers. And I showed you in one of the slides, we talked about Kubernetes and Azure, how easy it is now to integrate different environments on the cloud. So there's a wealth of information out there. Feel free to look at our website, and you can reach out to any of the contact points on the website. We have an upcoming conference, and this is a yearly conference where there's a lot of effort that goes into making this happen in a cutting edge manner. When I say cutting edge manner, you're going to learn about what is new and better in HPCC that is coming down the pipeline or that is being released very recently. So if you are interested in some of the use cases that we have, and you want to look at some of the other customers that are using the system, please feel free to attend the conference. It's completely open. All that you need to do is you have to go and register and attend. It's free. There's no charge to it. The whole HPCC ecosystem is open source and free as well. If you're going to use this in the cloud, obviously you have to pay for the cloud resources that you use, but the HPCC ecosystem and deploying that and all that is completely free. All our research material, documentation, everything is open source and free. So if you do want to learn more, feel free to attend our October 3rd to 5th conference. It's going to be fantastic. And that is all I had. So let's see if we have any questions.